There we go. Facebook finally got on board here. So welcome to the 14First Alert Weather Show at 9. I'm Jeff Lyons. Last day of July here, 31st, and we are finishing out what has been a drier and near normal temperature-wise month. I am watching your comments, as always, on the 14 News Facebook page, so you can chime in there if you like. Friday after 5, still going, I think. Not many people out milling about there, even though the rain finished out early in Owensboro. We do have more showers and some thunderstorms coming in overnight, and then it will be cloudy with occasional rain this weekend. Cool temperatures, we clear off and warm up again next week. Nothing over our counties right now, but if we look a little more to the west, you can see that line of showers and thunderstorms developing. No severe weather connected to it at this point. Our expectation is that it will weaken but continue to move our way, and we will hear some thunder overnight as that comes down and across mainly western Kentucky, but we could get some rain over southern Indiana and Illinois, but not a severe weather threat tonight, so you can sleep fine and enjoy the rain and maybe a little thunder out there too. That severe weather risk is only at a category 1 there of 5 over southern Illinois, and even I think the whole thing probably is a little overblown here. Saturday then the risk will shift to our east. We're fine here in the tri-state, no severe threat. Same for Sunday. It'll be cloudy with temperatures in the mid 70s, so we don't have a lot of the energy that we had to work with earlier in the week. Here's how our models play it out. We start with the graph model, our in-house model here, and you see some rain moving in there shortly after midnight and exiting to the east, and then additional showers kind of coming and going through the day on Saturday and Sunday. It also captures that spin there. We will have northerly winds and clouds wrapping around with the rain in there, and then that may linger into Monday. The other model here I'm going to show you too. This is the HER, and it also has some rain coming through overnight and then exiting during the day tomorrow. So pretty much the same solution on both models, which is a good thing. That gives us confidence that the forecast here that we put together will in fact be accurate, or as close as we can get it. So the coolest days here in the next 7 are over the weekend, and then by middle of the week we're back to close to 90, and it will become more humid toward the end of the week. We haven't really had much impact from the smoke from the wildfires today, and we're not expecting any with the rain and clouds over the weekend. You won't notice the smoke so much, but once that low pulls out, we may get another plume of it across the tri-state early next week on Monday and Tuesday. 77 right now, feels like 79, so the humidity isn't really adding much to the temperature out there, but it's noticeably more muggy than it was last night at this time, and it will stay kind of like that all the way through the weekend. We hit 65 this morning and got up to 83 this afternoon, so that's a good spread. It's both temperatures there a little below normal. That finishes out our month with a string of 80-degree days and no additional rainfall. So July will go in the book as below average by 2.5 inches of rain, and for the temperature, we're about not quite a degree warmer than normal. There's a little more action now along the riverfront. Where were they a minute ago? It was like a ghost town. Maybe that was a frozen picture or something. The rainfall then deficit now ranks among the driest of the months that we've had relative to the rainfall deficit. So April is comparable, February is comparable, and we need a little more rain, that's for sure. Many of you have had rain, I get it, but we need widespread soaking rainfall at least every week or two through the summer to keep things on an even keel. Scattered rain tomorrow as you head out and about. That low pressure is diving out of Iowa. Will come across Illinois and land over around Louisville by tomorrow afternoon. And as long as it's that close, it's going to keep the atmosphere unsettled or churned up, so we have the clouds and rain wrapping around, and pretty much, same old, same old. Next week then, it's mainly dry. We could see an isolated or pop-up shower possible each day. And then we have another shot at some more organized or widespread rainfall coming our way by Friday and maybe Saturday, at least the way the GFS is portraying it, with rain amounts at about an inch for the week there, a little less than that. On the European model, we get clear on Monday, and then some of that rain and cloudiness backs in on Tuesday. Scattered showers. Wednesday, Thursday, dry, and then we have rain moving in for Friday, but not Saturday, and the European also coming up with about an inch of rain over that period. So the bottom line here is next week will kind of be unsettled. You know, a pop-up shower can't be ruled out once it gets warm and humid out there, but we don't have any cold front or tropical system or anything to really kick anything up. 72 tonight, 78 tomorrow, occasional showers during the day, and then those warmer temperatures roll in by the middle of next week and hang around. We should stay above normal temperatures through the middle of August and drier than normal as we wait for more rain. There's Snoopy peeking in on us among the leveler blinds up there. So I have a cat that looks just like that. Those are pretty common, those tuxedo cats. They all kind of have the same general probably demeanor and look to them. All right, let's see here. Yeah, we got a bunch of questions. Laura Gray's on from Dawson Springs. Hey, Laura. And Cheyenne Hammonds is watching, as always. Let's see. Justin Turnage is apologizing for taking over on the radio. That's all right. We like talking shop back here. We can do that. We're not on some broadcast time clock. Heard anything about phased array Doppler? Hopefully it'll replace the current radar. Yeah, I won't go way down the rabbit hole for Justin, but he's talking about phased array radar, which works a lot differently than what we use today. We have a parabolic dish that goes around, shoots out a narrow beam, kind of like a rifle. And the best way I can make the contrast is phased array is emitting like a shotgun. So you're getting the whole volume, everything, bang, in one whack. And correct me if I'm wrong on that, Justin. That's kind of how I understand it. There's a prototype phased array operating, I think, probably in Norman for the National Severe Storms Laboratory. And yeah, they're hoping to roll that out. The current radars were rolled out, or the prototypes came out in 1988, which is why it's a WSR-88D for Doppler. And if you look historically, the previous big release was in 1957 and 1988. So yeah, we're due. You know, I mean, we've been running these radars now almost 40 years. So I would think within the next 5 to 10 years, you would see a rollout of phased array. They have done, they did a service-like extension on the current radars, and part of that was doing a dual pole, and the second, they were able to get even a smaller, what am I trying to say here? The width, the beam width, down to a ½ degree. And so prior, I think it was 0.8 or a degree. And so they've managed to wring more data out of the current network. And then they all have received new pedestals and the transmitter receiver, you know, hardware upgrades and that to keep them going. So they're trying to keep them alive as long as they can. But the network is pretty robust. Suzanne Daly is watching, Ricky Brown watching and thanking me. Well, you're welcome. This is what we do. Jeff Miller, last night's show was informative. He enjoyed it. See, you know, for the ones that you know we're like sweeping under the chairs and turning the lights up. Yeah, it was a long dissertation, but you know, I'm happy to do it if it can help somebody understand a little bit some of the technology that we look at. Let's see. There was another question, phased array. Okay, I think I answered phased array. I don't have a picture of phased array. It's kind of funky how it works because we're accustomed to seeing, you know, a ball, a radome that shields the mechanism, the pedestal and the dish, right? And then there's a feeder horn on there and all these different things. I really talk with my hands. And phased array, at least the one that I saw, it's kind of square, and I can't remember if it has to rotate or if if that's the benefit, there are no moving parts. It simply emits a signal and the return, and then it processes the data. Something interesting for Jeff Miller and Ms. Turnage here is that the Doppler radars operate. I can't remember the exact figure. It's a lot. It's like, I want to say 750,000 watts or something like that. But it's a very, very tiny pulse of energy, and the radar is actually only broadcasting, if you will, or emitting a signal. In an hour, it's like 7 seconds of energy going out, and then the rest of the time it's listening. And the radar operator can determine the distance between basically when it pings or when it sends a signal out and it comes back in. And of course there are trade-offs when the pulse repetition interval, the PRI, and I can't remember the relationship, but essentially you get better data with the longer thing, but you miss out on resolution. Maybe that's what it. Anyway, so there's like a fine line, and if you're really into radar and you look at say radar scope or radar omega, where it will tell you the volume strategy, the VCP, which is the volume coverage pattern, you'll notice they're all different ones. It'll be like clear air, which is the one they run when there's no precip, and that's the one that will show bugs and roost rings and all those things, because it's basically sending out a big signal and listening. When we get into preset modes, 212 is one. There's a bunch in there. Then the radar, they pull it back a little bit, because if they were still sending at that rate, it obliterates everything. You don't see the details, so you kind of have to pull it back. Kind of like having a stereo turned up too loud. So you turn it back so you're not getting distortion. And then in addition, there are there are many, but the two I'll talk about, there's a mode that the radar runs in called SAILS, S-A-I-L-S. And that is, I don't know what the acronym is. The government is rich with those. But essentially what it does is we're interested in severe weather in the lowest cut, or the lowest revolution of the radar, which would be about a ½ degree above the horizon. So it goes around once, then it goes up to a degree and a half, and so on. It takes it about 4 or 5 minutes to do a volume scan, to go all the way up to 19½ degrees and back down. When we have severe weather, what they do is they'll do the lowest cut, then they'll do a couple, then it comes back down, does another cut, and then up, and it does all this stuff so that we get more timely, low-level information. And when the radar, the actual machine is doing that, this is a big, gigantic 30-foot dish that's stopping, starting, moving, and everything. And the whole building, I was in the radome up in Owensville, and it was just going normally, right? But the technician told me that in severe weather, when it's really moving fast, you feel it, because it's a big piece of equipment. Anyway, I digress here. Oh, we're giving a shout out to Darren, Ryan Nance's co-worker. Well, how did the boss and Becky and what was his name? I can't remember. Rebecca and something, Nick and Rebecca, whoever it was that was getting engaged. Did you get a promotion, a raise, a better parking spot? Hopefully you got something out of it. Of course, they would had to have been watching our little club here, and I don't know how many people actually that this is appointment viewing for. Carolyn Lovelace is sitting outside in Hopstop with the cat. Nice out. I wish I still had cats that went outside. It seems like it tempers them a little better. Mine stay in now, and if I bring them out, they go berserk, and I don't like chasing them and all that stuff. So, but back when I had Betty the weather cat, she was an indoor-outdoor cat, all-American, and loved to be out. Would stretch out, and let the wind blow her fur, and then go eat a squirrel. Angie Wampler, good evening from Vincennes. Good evening. I think we got everybody in there. I had actually a follow-up to Jeff Miller's question about gorilla hail. He had asked me what that was, and that's a Reed Timmer term for very, very large hailstones, right? And we've talked here on this program many times about how hail forms. Basically, updrafts carry raindrops up above the freezing level. They freeze. That nucleus of ice then can pick up additional layers of ice as it tumbles around in the storm. And once it gets too heavy, it falls back down to earth. The gravity pulls it back down. And the size of the hailstone is governed by the strength of the updraft. Stronger the updraft, the bigger the hailstone can become. And so when we're talking about gorilla hail, let's see here, there we go. When we talk about gorilla hail, which would be, you know, probably over here in the grapefruit size and larger, you would need an updraft of about 98 or greater miles per hour to hold that up, which is why you don't see gorilla hail very often here in the Midwest. You see it out in the plains more with those big supercells that have that access to that kind of an updraft. But it takes a lot. And a lot of the knowledge that we have about hail is being re-examined by the scientific community, how hail forms, how it tumbles through the atmosphere, how that affects the shape and size of the stones, etc. They're using this gigantic piece of equipment with a light on it that's like brighter than the sun. You can't, you know, I don't know if they wear like eye protection or what, but they point it away and then they use super high-speed photography. And so by looking at that, you can tell, you know, how these pieces of hail are moving through the atmosphere. And it's not really known for certain that the method I just showed you is actually how hail forms, because not every thunderstorm has hail. There are only certain conditions where you'll get hail. One is you have to have the sub-freezing level has to be pretty close to the ground or to the base of the storm, and of course you have to have the big updraft. But even when those conditions are met, you don't always get large hail. And efforts to use the radar to estimate hail size are also flawed in some ways. There's a general correlation that the higher the VIL number, or vertically integrated liquid, the larger the hail will be. But it's not a lead pipe cinch. You can't just look and say, oh, the VIL's 80, the hail must be 0.8 of an inch in diameter. That would be way too easy in our line of work. But there's a general correlation. The bigger the VIL, typically the larger the hail can become. All right, let's see if we have anybody else in here. Jeff Miller talked to Reed Timmer a few years ago about a project he was working on. Well, son of a gun. Well, then, did you meet him at the Depot Diner? How did you run across Reed Timmer? There's a whole podcast right there. Justin Turnage says the record hail was broken 4.55 inches, I think. Is that right? Not sure. If we want to get into weeds, we can talk about the SCU-T log P graph. Oh, that'll be fun. He's referring to atmospheric soundings, and yeah, that's a whole can of worms. And I don't have any graphics here to really show you a SCU-T chart, but they are very useful, especially for severe weather forecasting and just general cloud cover forecasting and things like that. Brandy's in Melody Hill tonight. Brandy Eagles, all right. Glad to have you with us. Right out there by the airport. You got that big bomber flying over. I think that's tomorrow. The big B-29 will be flying over. I got to fly in a B-17. That was back in 1997, I think. 6 or 7, long time ago. And they had a media availability, and so I took it. And part of the deal was Tri-State Aero back then flew us in a small plane, like a Cessna, up to Terre Haute. Then we got out, walked across, got into this bomber, this B-17. And it's not like flying commuter to Cincinnati. You know, you basically sat on the floor, and they had these seat belts that you put on, and we took off. I mean, there aren't seats in there other than where the pilot sits and the bombardier sits. And then once the plane was off the ground, we were free to walk around. We could go anywhere in that airplane except for the ball turret, which is underneath. They have machine guns down there, and you can't access that while the plane is in flight. And then the bomb bay, where the bombs were, of course, is closed, and you could walk around it, but we didn't go back there. But the fascinating part was in the front. Of course, the pilots sit up, and then below them and a little bit ahead is where the bombardier sits. And he has a special tool called a Norden bomb sight, and he looks through that, and it's got crosshairs and azimuth and everything. So he's looking through that at the ground and then releases the bombs at the appropriate time. And of course you could sit in there and look through the scope, and you couldn't release bombs. Otherwise Sullivan, Indiana would be off the map, right? Push the button. Nothing against Sullivan, that's just where we were when we got up to the bombardier's position. Really fascinating. And of course those aircraft are all mechanically operated, so when the pilot is moving the yoke, there's a cable and a linkage that goes back. It moves the ailerons, the rudder, the pedals, everything is all connected. You can see the cables running through. They didn't pretty up these planes. They were built to go into service and drop bombs. So you can see all the mechanism in there from World War II, which was interesting, very interesting, and really made you think about those men that were in those planes during the war. But anyway, we flew from Terre Haute to Evansville. I think we were only up maybe 300 feet. I mean, we were close and essentially followed Highway 41. We took a little turn at Lawrenceville and buzzed that airport, and then we came in over Melody Hill and landed at Evansville Regional. And it was a smooth flight, and you were able to stand up. They had sort of a top part of it open, so you could stand there and look up at the tail and down, and it was really a unique experience. I've got video somewhere. I should digitize that, share it one of these days. A product for down the road, right? Justin Turnage, So Much History. Yeah, you should go out there. Go this weekend. They've got the B-29s parked out there. You can walk around it and I don't think you can kick the tires, but you can get pretty close. And getting into those aircraft is tricky. You kind of go up a ladder through a tube. I mean, you got to be, willing to. It's kind of like spelunking. You got to go up into this big machine and do all that. Okay. I think we just about. Jeff Miller called Reed Timmer. Lexan related. Oh, I'll bet he was getting. I didn't know you worked at GE or Sabic, whichever it was. You're probably at GE if that's Lexan. Sabic bought it and they still made the plastic. So yeah, Lexan is that like ultra tough glass. It's not glass. It's like a polymer, but you can see through it like a window. And I imagine Reed Timmer has that on all of his windows since he has a tendency to drive into hail and 100-mile-an-hour winds. Let's see. We have indeed talked to everyone here on the line, so I'm going to let you back to what you were doing. We have women's NBA tonight, so we will be on, I think the news hopefully will come on at 11. We'll be late, so this might be the last weather you see if you don't make it through the end of the ball game. Byron Douglas will be here tomorrow, and I'll see you again on Sunday if you don't catch me on 14 News after the game. Thanks so much. Stay safe. Have a good weekend.